evening, everyone. I'm Calvin Joseph, and today I'll be conducting your NPTEL network analysis and problem solving and doubt clearing session I will conduct. And today we will be considering about Laplace transform and the application of Laplace transform for solving the various electrical circuits which we have considered till now. And we will see how the Laplace transform can make our problem solving easier, as well as it is like a unified method which we can use and which we can apply to our systems. There are certain rules for Laplace transform which we will consider. Okay, so I'll begin.
Sir.
So we are considering today week 6.
Yeah.
Week 6 we are considering Laplace transform.
Yes, sir.
So we had studied about various electrical circuits, and we have a resistor, inductor, and capacitor, etc. are present in our electrical circuits. So the voltage across the inductor is given by L into di by current to the capacitor is given by C by dt. So to solve this, so Mota, you are not talking, you can mute actually. Well, when you have doubts, you can unmute and ask. Otherwise, keep it muted. So, so there are these various relations are there between the voltage and current for these energy storing elements, and these are result in what are known as differential equations. So when solving differential equations for our electrical circuits, we need to find what is known as the auxiliary equation. Then we had to find the solution of the auxiliary equation to find its solution. Then we had to find the particular integral. So this is the first part. Then we had this part 1. Then we would do particular integral. We will find. Then after that, what we will do? The solution is the combination. Our solution is auxiliary equation plus our particular integral. Then after that, we will apply our boundary condition. That is our, what are boundary conditions? It is your initial condition as well as your final condition, etc. After doing all this, then we will find the solution. We will find the complete solution we will get. So this is the entire process when we are solving differential equations. And then we have to do integration also we have to do. And we have to consider all these aspects while solving these differential equations. So it makes it a bit complicated. So there was a person, Laplace, and he formulated this method of converting differential equations into a set of algebraic expressions. So what is Laplace transform is, if there is a function x of t, it is converted in terms of x of s. Okay, and this is known as your Laplace transform. So as an example, let us consider e raised to at. This function e raised to at has a Laplace transform which is given by 1 upon s minus a. So what will be the Laplace transform of e raised to minus at? Can anyone tell me?
1 by s plus a.
Will be 1 by s plus a. Okay?
A.
Yeah, correct. Then, so these relations are there, and these are very useful relationships which you should know. Okay, Then one more aspect is, consider we have sin 80. What is the Laplace transform of sin 80?
Sin it equal to a by s square plus a square.
Yes, these are important ones. And what is the Laplace transform of cos 80?
Cos it equal to a by s by s square plus a square.
Okay. Okay, so these are certain relations which are very standard relations which we have, which we will find very useful while solving our differential equation, while solving our electrical circuits using Laplace transforms. Okay. Then there is one more aspect is, what is the Laplace transform dx upon t by dt? What is its Laplace transform?
Laplace transform is x of s
Yes.
s into x of s minus x0.
So it is s of s minus x of 0. Correct.
x0 initial condition.
Yes, yes. Okay. What is the Laplace transform of integration of x of t into dt? What is this Laplace transform?
That is equal to x of s by s.
Yes.
X of s by s.
By s. Correct. Okay. So I hope this part is clear, right?
Yes, sir.
Hmm. Okay. Now, for so these are certain relations which we have for Laplace transform. Further, one more thing I would like to add is, what is the Laplace transform of x of t minus a? What is the Laplace transform of this?
X of t minus a. That is
No, no,
e to the power
no, not that.
x of t. Integration of x.
No, what is Laplace transform e raised to at x of t? Okay, this Laplace transform is x of s minus a. So for an example, let us consider e raised to at sine bt. Okay, we know for sine bt, the Laplace transform is, what is the Laplace transform of sine bt? Hmm? What is the Laplace transform of sine bt? Okay, the Laplace transform of sine bt is b upon s square plus b square. Now, in case we have Laplace transform of e raised to at sine bt, its Laplace transform will be given by b upon, and where s is there, you replace it by s minus a. So it will be b upon s minus a square plus b square. It is just this change. So over here, where s is there, we replace it, where s is there, I replace it by s minus a. That's all I have to do. Is this part clear?
Sir, please repeat once again. My net is sir off for some time.
Okay.
E to the power 80 of x of t is x of s minus a.
So if I have
Then Laplace of okay sir. Then Laplace of bt equal to b by x square plus b square.
Hmm.
Right, sir.
So
Laplace of a to the power b1. This means yes, sir. Clear, sir.
yeah, no? Okay.
Yes, sir. Yes, sir.
Mhm. Achha. So now this is done. Now, can you tell me for consider? So do you guys know what are partial fractions?
By partial fraction, we can find the Laplace inverse.
Yeah.
Easy step to get the Laplace inverse.
Okay. So there are partial fractions is very useful because when we are finding the Laplace inverse, we want them to be in one particular form, which is easy for us to take the Laplace inverse. So suppose we
Yes, sir.
have
Yes, sir.
1 upon s plus a into s plus b. Okay, we do not have the Laplace and we want to find the Laplace inverse of this. Okay, this is difficult for us
Yes,
to
sir.
do. So we know
Yes, sir.
the Laplace inverse of 1 upon s plus a is e raised to minus at.
Minus 80.
Similarly, the Laplace inverse of 1 upon s plus b is equal to e raised to minus bt. These are very
BT.
standard formulas. So we want it to be in this form of 1 upon s plus a and 1 upon s plus b. So what do we do in such a cases? We have 1 upon s plus a into s plus b. According to the theory of partial fractions, we can write it to be of the form sum a upon s plus a plus b upon s plus b. Okay.
Yes, sir.
So now what is unknown to us over here?
AB.
Capital A and capital B, right? So what do we do is we cross multiply. We cross multiply. Okay. So we get 1 upon s plus a into s plus b. This is equal to a into s plus b, small b, plus capital B into s plus small a upon
Okay.
s plus a
Good one.
to s plus b. Okay. So now the denominator is common. It is the same. That means we can equate the numerator. So we get 1 is equal to a upon capital A is into small s plus b plus capital B into small s plus a is equal to 1.
Plus
Then what we do is
8.
we write 1 is equal to s into a capital A plus capital B plus capital A into small b plus capital B into small a. Okay.
Yes, sir. Yes, sir.
So now what do we do? This 1 can be written as 0
Comparing the both sides.
s plus 1 is equal to s into a plus b plus ab plus ba. Okay. So now what we do, we compare both the sides.
Compare the both sides. Sir.
So what are we comparing? We are comparing s and s. What are their coefficients? So coefficient of s over here is 0 and here of coefficient of s is a plus b. Okay. This is one. There's another equation. Coefficient of this s. This is 1 is equal to a into b plus
1,
b.
1.
Okay.
B into A.
Yeah, b into small a.
Yes, sir. Yes,
So
sir.
here what do we get? We get a is equal to minus b from this equation.
Yes, sir.
Then we put that in this equation. We get 1 is equal to minus b into capital B plus capital B into a, right? So we get 1 is equal to B,
Yes, sir.
A minus B. So we can write further that my B is equal to 1 upon
Yes, sir.
A minus B. Okay. And my A is equal to minus B, that is equal to
Right, sir.
minus 1 upon A minus B. Okay. So these are the steps for me to find the partial fraction. So now what I do is, I can write my 1 upon S plus A into S plus B, that is equal to capital A upon S plus A plus capital B upon S plus B. Right? I substitute this value of A, B and this value of A. I will get it to be minus 1 upon A minus B into 1 upon S plus A, right? Plus 1 upon A minus B into 1 upon S plus B. Okay. So now I will take my, so now I have written this equation in this simple format. Now I can take the Laplace inverse. So I take the Laplace inverse of 1 upon S plus A into S plus B. That I can write it as Laplace inverse of minus 1 upon A minus B into S plus A plus Laplace inverse of 1 upon A minus B into 1 upon S plus B. That turns out to be equal to minus 1 upon A minus B into e raised to minus at plus 1 upon A minus B into e raised to bt. Is it clear?
E raised to minus BT.
E raised to minus bt, yes, correct.
Yes, sir. Yes, sir.
So this is how something which was very complex.
Minus BT. Minus BT.
Minus, you know?
Yes, sir. E to the power minus BT.
हाँ वो लिख दिया मैंने. So that is how something which is very complex, using partial fractions, we can write it in this form. All right. Then so I hope you have understood the concept of partial fractions. Now we will
Yes,
consider
sir. Yes, sir.
what happens for an inductor. Okay, I have an inductor. This is my inductor L, and this is my current flowing through my inductor. Suppose at time t equal to 0, the current through my inductor was 1. Okay. Then how will you represent? Okay. First, this is my inductor. This is my IL. Right. So we know
Yes, sir.
this is my voltage across my inductor. We know VL is equal to L into di by dt, right?
Yes, sir.
So if we convert it into Laplace domain, we get VL of S is equal to S into L into IL of S. Is this clear?
Yes, sir.
So this is how we write. Similarly for resistor, it remains the same. A resistor remains as a resistor either in Laplace domain or in time domain. Okay. But a capacitor, it gets replaced by, we write it as 1 upon SC. Okay. Inductor is written as S into L.
S into L.
Oh. Okay.
So here BLS equal to SL ILS. If initial condition is not taken,
yeah, if initial condition is not taken,
then not taken, then this is the case.
yes, yes. Okay.
Yes, sir.
So now, let us consider. So we'll start solving the sums. Because then we will. Then if we require something theory, we will. I'll teach there. Okay. Let us consider this sum.
Yes, sir.
This-
Yes, sir. Yes, sir.
So in this circuit, we have to find VC of t, I1 of t, and I2 of t. These are what we want to find out. Okay. We want to find out what are those
Yes, sir.
values. So also let us see what does the question say. The switch is closed at t equal to 0. Now, before that, a capacitor was charged to VC of 0 minus is equal to 10 volts. So that we have to write down. Our
Yes, sir.
VC of 0 minus is equal to 10 volt. And there
0
was,
minus equal to 10 volt.
yeah, and there was no current through the inductor. If there was no current through the inductor, that means what? I1 of 0 minus is equal to 0. So we have I1 of 0 minus is equal to 0 ampere. Okay.
Yes, sir.
Now we want to find for time t greater than or equal to 0, the currents I1 of t, I2 of t, and the capacitor voltage VC of t, we have to find their expressions. Their expressions in terms
Yes,
of some e raised to power k into sine. Okay, in terms of that. So we have to find all these values. We have to make sure that A1, A2, AB are greater than 0. And these angles lie in the range minus pi to pi. Okay. So these are certain conditions that A1, A2, AB should be greater than 0. So these should be between minus pi to pi. So let us start solving it. So we first write the circuit in Laplace domain. So if I write the circuit in Laplace domain, what I will get? This I will get it to be 18 into S, right?
Yes, sir. 18 into S. Yes.
Get as 102.
Yes, sir. Yes, sir.
This I will get it to be 1 upon
612
SC,
by S.
612 by S, right?
By S.
Yeah.
Yes, sir.
And the voltage across the
The
capacitor
current is VCS.
that is 10 upon S.
This.
VC of 0 minus divided by S, right? Any doubt in this?
Yes, sir. Initial voltage. Yes, sir. Initial voltage is 10 by S. Okay, sir.
Okay, so by this has come because of the initial voltage condition. So now we have to solve this. So suppose this is my I of t. Okay, this is my I1 of t.
I1.
This is I2
This
of
is,
t.
yes, sir.
Okay. So we have to find these equations. So because it is in Laplace domain, we write it in terms of s. So we have I1 of s plus I2 of s is equal to I of s. Right?
Yes, sir.
This
Yes, sir.
current I
Yes, sir.
of t is I1t plus I2t. So I of s is equal to I1s plus I2s. So how much is that
Yes,
current?
sir. Yes, sir.
That current is this voltage divided by the impedance. Okay, so that is voltage divided by the impedance. So what is the voltage over here?
10 by S.
So this the voltage is 10 by S and the impedance is Z, Z of S. So my Z of S is the combination of this one, voltage across this impedance of the capacitor plus parallel combination of this. Okay. So it is 102 into 18S divided by 102 plus 18S. Is this part clear?
Yes, sir. You have to proceed. Capacitor with the series with the, yes, sir. Yes, sir. L and R combination.
It will remain same. Depend on that. Okay. So,
Okay.
so what do we do is we cross multiply. So this we will write it as 1 into 102 plus 18s plus 102 into 18s divided by s into 102 plus 18s. Okay. So my s is equal to, where's my calculator? Just 1 minute, I'll get my calculator. What is 102 into 18? So Z of x is equal to 1836 s square. Okay. Plus 612 into 18. That is 11016 s plus 612 into 102. You are still in college, huh? Hello.
Yes, sir. Yes, sir. Yes, sir.
Okay, so what is 612 into 102?
And this is the college time.
Oh, okay. What is 612 into 102? So it comes out to be 62424.
62424.
Divided by s into 102 plus 18s. Okay. So we have my I of s. My I of s equal to 10 by s divided by z of s. That is equal to, so this is 10 upon s divided by 1836 s square plus 11016 s plus 62424 divided by S into 102 plus 18S. Okay. Now there is a property of how do we, when these are like sort of fractional elements. So when we divide, what do we do? Suppose there is A upon B divided by C upon D. This can be written as A into D divided by B into C. Okay, so this numerator remains at the numerator while the denominator or the bottom one comes to the top. And this denominator comes to the bottom. Okay. So if we use that, what do we get? I of S is equal to 10. This numerator goes, this denominator goes on top. So it is 10 into S divided by into 102 plus 18S. This S comes down, so it becomes S into what was this term, which is 1836 S square plus 11016 S plus 62424. Okay. So now what do we have? We cancel this S and S. So we get I of S is equal to 10 into 102 plus 18S upon 1836S square plus 11016S plus 62424. Okay.
Yes, sir.
So now we want to find I1 of S. Okay, I1 of S. So what is I1 of S in terms of I of S?
I1 of S equal to I of S into 102 by 102 plus 18S.
Correct. So we consider that. So we have I1 of S is equal to 102 divided by 102 plus 18S into I of S. I of S is what? Into 10 into 102 plus 18S divided by 1836S square plus 11016S plus 62424. Okay. So
Yes, sir.
this and this get cancelled. So we get it
Yes, sir.
get it as I1 of S is equal to 1020 divided by 1836S square plus 11016S plus 62424. Okay.
Yes, sir.
So what do? We take 1836 common. So we get this to be 1020 upon 1836. So this becomes S square. So we have to divide 11016 divided by 1836. What is that? How much is it? So that comes out to be 6. So it comes S square plus 6S. Then what is 62424
Yes, sir. I have no
divided by 1836? That becomes 34. Okay.
Yes, sir.
So my I1 of S. So what is 1020 divided by 1836? It comes out to be 0.555 upon S square plus 6S plus 34. Okay. So now I want to ask a question. What are the roots of this? What are the roots of this? what will be the roots of this? So if you see s square plus 6s plus 34, if you equate it to 0, the roots, what will you get? You will get it to be minus 3 plus or minus 5i. Okay, these are the two roots. These are the complex conjugates. Okay, these are complex conjugates. So, so how do you know if there's an equation s square plus this as square plus bs plus c equal to 0? If b square is less than 4ac, then the roots are complex. Okay, this is a condition which you must remember.
Yes, sir.
Because in the exam, in the GATE exam, you will not have the calculator to be able to find out the exact roots. So you must use this condition to know if the roots are complex. Okay. So now in our case, what is b?
Yes, sir.
It is 6 square. Less than, okay, what is it? Is
B
6
is 6.
square. That is equal to 36. And what is 4 into AC?
Mm. 4 into 1, 4 into 34. 136.
It is 136. So we have 36 is less than 136. Okay. That is why we know our roots are complex conjugates. Okay. Now we found out that our roots are complex conjugates. Then what should we do? So we must have, suppose we have this equation, s square plus 6s plus 34. We write it on the form s square plus 6s plus 6 upon 2 ka square plus 34 minus 6 upon 2 square. That comes out to be 6 square plus 6s plus 3 square plus 34 minus 3 square. That comes out to be s square plus 6s plus 9 plus 34 minus 9. That comes out to be s plus 3 the whole square plus 25, which we further write it as s plus 3 the whole square plus 5 square.
So please repeat the 5 are plus 6 by 2 the square and minus 6 by 2 the square.
Okay, so we wanted to get in the form of a square, s plus 3 square form. So we don't know what should be that value. So what is the mathematical way is, whatever is this value, we divide it by 2 and we take the square of that. Okay. So if you want this to be equal to this, if you add something, you have to subtract the same value. So that is what we are doing. So we are adding 6 upon 2 the square, and then we are subtracting also minus 6 by 2 square. Then 6 by 2 is 3, so 3 square. This is minus 3 square. This is s square plus 6s plus 9. This is 34 minus 9. Then we combine. So this entire thing and this entire thing we combine. So
Sorry, why you are doing this?
This I will tell.
Why you are doing this? As the roots are complex.
Yeah, because the roots are complex, yes. Because the roots are complex, we have to go through this headache. So we have finally written s square plus 6s plus 34 as the
Sir,
form.
why sir, why take 3, not other number?
Because then only that 6s. Because if you see, if you know a, what is a plus b the whole square? Okay, let me change it. What is S plus B the whole? What is S plus B the whole square? So S plus B the whole square is S square plus 2BS plus B square, right? Okay.
Yes, sir.
So in our case, we know 2B is 6. That is why we need to make this 6 upon 2 square. Okay.
Yes, sir. Yes, sir. Yes, sir. S plus B the whole square.
So this is the thing when you do when there are quadratic equations that is raised to 2 with complex roots. This is the way you have to follow. This is the step. Okay. So now we go here. We got I1 of S is 0.555 upon S square plus 6S plus 34. So we write our I1 of S is equal to 0.555 upon S plus 3 the whole square plus 5 square. Now we have to take the inverse Laplace transform. What will you get it to be? So we get I1 of t so we will get I1 of t is equal to 0.5555 e raised to minus 3t into sine of 5t into 1 upon 5. Okay. That means I1 of t is equal to 0.111 into e raised to minus 3t into sine of 5t. Okay.
So there is in upper part there will be no 5, so I multiply 1 by 5. Okay.
Yeah. Exactly. Because you know sine 5t Laplace transform is 5 upon s square plus 25.
Yes,
So we have 1 upon s square plus 25. So that is equal to 1 by 5 sine 5t.
sir.
Okay.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Understand.
Yes. So we have finally found I1 of t. Now we want to find I2 of t.
Yes,
So what do we know?
I of S minus I1 S.
That could be done, but we don't know what is I of s till now. We have not solved it.
I of S will not.
What we will do is we'll do we know I2 of s into 102 is equal to 18s into I1 of s. How do I get this? The voltage over here is common.
Yes, sir. Yes, sir.
18s into I1 of s is equal to 102 into I2 of s.
I1.
Okay. So I'll go to a new page. I2 of s is equal to 18s upon 102 into I1 of s. Okay. So that becomes equal to 18s upon 102 into 0.555 upon s plus 3 the whole square plus 5 square. So this is my I2 of S.
Yes, sir.
So what is 18 into 0.555 divided by 102?
Okay.
It comes to be of this form. Is this clear?
Yes, sir.
Now can we take the
Yes,
inverse
sir.
Laplace transform?
Yes, sir. Yes, sir.
How?
F equal to 0.09 into e to the power minus 30 into sine 5t.
Into sine.
E to the power minus 50 into sine 5t.
Sine phi t. Why sine phi t?
Sine omega t.
This is S, no? S is here, no?
Yes, sir. Yes, sir.
Okay, so I'll write. We know S upon S square plus B square. This is equal to cos BT. Okay? But over here, we do not have
Yes,
just
sir. Yes,
S
sir.
square over here. We should have S plus A. We have S
Yes,
plus
sir.
A
Yes, sir.
upon S plus A, the whole square plus B square. That is equal to e raised to minus AT into cos of BT. Okay?
Yes, sir. Yes, sir.
But we cannot do this over
Cos
here
of
because it is just S. It has to be made into S plus 3. So we have to write I2 of S should be equal to 0.098
0.9803
into S
e to the power minus 30.
minus 3. I have to add plus 3 and I have to subtract minus 3. Also at the same time. Okay. I want to retain the same value, but I also want it in terms of S plus 3. So I have to add plus 3 and I have to subtract minus 3. So I will get upon S plus 3 the whole square plus 5 square. This comes out to be 0.09803 into S plus 3 upon S plus 3 the whole square plus 5 square minus 0.09803 into 3, that is minus 0.29409 upon S plus 3 the whole square plus 5 square. Okay. So can you take the inverse Laplace transform of this now?
Yes, sir. Yes, sir.
So what is the inverse Laplace transform of this? What is I2 of t?
It will be 0.09803 into e to the power minus 30
Okay.
into cos 5t
Okay.
minus 0.29409 into sine 5t. Sorry, e to the power minus 30 into sine 5t.
Into
E
sine
to the
5
power minus 50
divided by
sine
5.
5t. Oh, sir, yes, sir, yes, sir. Divided into 5, huh? Into 1 by 5.
Yes. Okay, that you must not forget. So
Yes, sir, yes, sir.
I2 of t becomes 0.09803 e raised to minus 3t cos 5t. What is 0.29409 divided by 5? So I2 of t is e raised to minus 3t into 0.09803 cos 5t minus 0.058818 into sine 5t. Okay, so have we found a solution? Yes, we have found a solution in one form, but in our question, they want the solution to be in the form of sine. Okay, so we want it to be in the form of sine. So what do we do is, we have to convert this cos into sine, etc. So how can we do that? So if we know a into cos of bt, okay, let me rub it. A into cos of phi t minus b into sine of bt, it is of this type. So what do? We will actually do, this is square root of a square plus b square into a upon square root of a square plus b square cos phi t minus b upon square root of a square plus b square into sine of phi t, right? We will assume a upon square root of a square plus b square to be cos of theta t, and b upon square root of a square plus b square to be equal to sine of theta t. Okay, so we get it to be of this form: a cos phi t minus b phi t minus b sine phi t is equal to square root of a square plus b square into cos theta t into cos phi t minus sine theta t into sine phi t. This is of the form square root of a square plus b square into cos of theta plus phi t. It is not cos theta t, it is just cos theta, sorry. It's just cos theta. Okay. Now we want to convert it in terms of sine. We know sine of pi by 2 plus theta is equal to cos. Okay, let me use another symbol. Sine of pi by 2 plus x is equal to cos x. So here, what is my x? My x is over here phi t plus theta. So cos of phi t plus theta is equal to sine of pi by 2 plus phi t plus theta. Okay. Is this clear? And what will be my theta over here? My theta will be, if you see over here, my a upon square root of a square plus b square is cos theta, b upon square root of a square plus b square sine theta. So my tan theta will be equal to sine theta upon cos theta, that is equal to b upon a. So this means my theta is equal to tan inverse of b upon a. Okay, my theta is equal to tan inverse of b upon a. Now I will substitute over here. So what is my, so I will get it to be my I2 of t is equal to e raised to minus 3t into square root of a square plus b square into sine pi by 2 plus phi t plus theta, which is equal to tan inverse of b upon a. So now what is my a and what is my b? My a is equal to 0.09803 and my b is equal to 0.058818. So if I substitute that over here, I will get I2 of t is equal to e raised to minus 3t into what is square, a square plus b square and the square root of that. That comes out to be 0.11432 and sine of phi t plus pi by 2 plus tan inverse of b upon a. What is that? Tan inverse of, that tan inverse of b upon a comes out to be 0.54042. Okay. So now pi by 2 is what? Pi by 2 is 3.14. So this pi by 2 is equal to 1.57. So this I2 of t is equal to 0.11432 e raised to minus 3t into sine of phi t plus pi by 2 is 1.57 plus 0.54042. This becomes 2.1112. Okay. This is the value. So this is my I2 of t. So any doubts in this? So Shubhakam, Hota, Suresh Babu, no doubts, no queries.
Yes, sir.
Okay, so this is my I2 of t I got. Now what will be my voltage across my capacitor? I want to find this voltage across the capacitor, Vc of t. So when it is closed, this is actually equal to my voltage across my capacitor, right? This is the voltage across the capacitor. The voltage across the capacitor is this entire thing. Okay? This is due to the initial condition. This is due to the impedance of the capacitor. So this is my entire voltage across my capacitor. So Vc of S is actually equal to 102 into I2 of S. Okay? So I can write Vc of S is equal to 102 into I2 of S. Or I can write Vc of T is equal to 102 into I2 of T. So I2 of T is 0.11432 into 102. So that is 0.11432 into 102. That comes out to be 11.66064 e raised to minus 3t sine of phi t plus 2.1112. Okay, is this clear? Or are there still queries in this? Vinod Kumar, Shubhakam Hota, Suresh Babu. Kindly make it interactive so that I will know how much you guys are understanding, where you are placing.
Clear, clear, sir, clear, sir.
Okay. Yeah. So now I'll proceed to the next sum. So this is question 2. Okay. So this is my circuit. So can anyone tell what is this 1.2H? What does this 1.2H represent?
Mutual inductance.
Sorry?
Mutual inductance.
Mutual inductance, yes. So also one more thing they have told, that there was no current was flowing. This is important. There was no current flowing. So I1 of 0 was 0. And I2 of 0 also was equal to 0. The current at time t equal to 0 is 0. So now, when you make the equivalent circuit, it will be like this. After the switch is closed, your 1.6 L inductor. Now, if you see at the dot, what is the voltage induced over here? Here current I2 is flowing out. If it is flowing out, then at the dot terminal, there should be a minus sign. So this becomes minus plus 1.2 into di2 upon dt. Okay, and for this dot, current is flowing into the first dot. So over here, the voltage will be plus minus 1.2 into di1 upon dt. Okay, into 0.9 Henry into 8 ohm. This is your I1 of t. This is your I2 of t. Is this part clear? This is because of the dot convention. This is from dot convention. Now this is complicated. So if we want to simplify, we take the Laplace transform. So we're taking the Laplace transform. And what is the converted circuit? That circuit is of the form, this 15 volts will become replaced by 15 upon S. 100 ohm will remain as it is. 1.6 Henry will be represented by 1.6 S. This will be represented as 1.2 S into I2 of S. 1.2 S into I2 of S. Okay. Over here, it will be represented as 1.2 S into I1 of S. This is 0.9 S. And this is, sorry. And this is A2. This is my I2 of S. This is my I1 of S. So is this transformed circuit clear?
Yes, sir.
Okay. Now what do? We apply KVL. We'll apply KVL in the second loop. If I apply KVL in loop 2, what I will get? 1.2 S I1 of S minus 0.9 S plus 8 into I2 of S is equal to 0. Okay. This is the equation.
Yes, sir.
So I will write 1.2s into I1 of s is equal to 8 plus 0.9s into I2 of s. So my I2 of s is equal to 1.2s I1 of s upon 8 plus 0.9s. So I wrote I2 of s in terms of I1 of s. Now I will apply KVL in this loop, in loop 1. When I apply KVL in loop 1, what will I get? 15 upon s minus 100 plus 1.6s plus 1.2s I2 of s. So it will be 15 upon s minus 100 plus 1.6s into I1 of s. Then minus to plus, so plus, it is plus 1.2s into I2 of s is equal to 0. All right?
Yes, sir.
So we write it as 15 upon s is equal to 100 plus 1.6s into I1 of s minus 1.2s into I2 of s. This is equation 1. This is equation 2. So we put 1 in 2. What do we get? 15 upon s is equal to 100 plus 1.6s into I1 of s minus 1.2s into 1.2s upon 8 plus 0.9s into I1 of s. Okay. So we write it further as 15 upon s is equal to 100 plus 1.6s into 8 plus 0.9s minus 1.44s squared upon 8 plus 0.9s into I1 of s. Is this clear? Okay, there's an error. This actually is 10 ohm. 10 ohm. So this should be 10. This should be 10. Okay. So 1 0 will go. 1 0 will go. 1 0 will go. 0 will go. Okay. Now we'll further solve. So we get 15 upon s. What is 10 into 8? That is 80. Plus 1.6 into 8. That is 12.8s. What is 0.9s into 10 is 9s. And 0.9 into 1.6 is 1.44. So it is 1.44s squared minus 1.44s squared divided by 8 plus 0.9s into I1 of s. So that becomes 15 upon s is equal to 12.8 plus 9 is 21.8. So 21.8s plus 80 upon 8 plus 0.9s into I1 of s. So we get I1 of s is equal to 15 into 8 plus 0.9s upon s into 21.8s plus 80. All right. It has come out to be of this form. Now, what would you suggest I should do to further solve this? Huh?
Partial fraction.
Sorry?
Partial fraction.
Partial fraction. Correct. So you are correct. You have to do partial fraction. But one more thing I recommend before doing partial fraction is this S. S. These things should have coefficient 1. It is preferred that they should have coefficient 1. For me, I prefer to do that. It makes solving it easier, simpler for me. So what I do is I1 of S is equal to 15. I will take 0.9 outside. So it becomes 15 into 0.9 into S plus 8 divided by 0.9. Okay. This is S into 21.8 into S plus 80 divided by 21.8. Okay. So this will be of what? What is 15 into 0.9 divided by 21.8? That actually is 0.619.
0.619.
Yes. What is 8 divided by 0.9? 8.8888. And what is 80 divided by 21.8?
3.669.
3.669. Okay. 3.669. So now I will get my I1 of S. I will write it again. It is 0.61926 upon S plus 8.888. Okay. Upon S plus 3.669. So now this I will write it of the form to be equal to A upon S plus B upon S plus 3.669. Okay. So when I do cross multiplication, I will get 0.61926 upon S plus 8.888 is equal to A upon S plus 3.669 plus B into S. Is it okay? I do cross multiplication. So if I want to find the value of A, I will put S is equal to 0. If I put S equal to 0, what I will get? I will get 0.61926. S is 0, so into 8.888 is equal to A into S is 0, that becomes 3.669 plus B into 0 is 0, so that is 0. So my A will be equal to 0.61926 into 8.888 divided by 3.669. So what will you get A to be? I will get it to be 1.500. Is there any doubt in this step? Any doubt or query in this?
No, sir. No, sir.
Okay, if I want to find the value of B, I will put S is equal to minus 3.669. So I will get 0.61926 into minus 3.669 plus 8.888 is equal to A into 0. Because if it S is minus 3.669, so minus 3.669 plus 3.669 becomes 0. So it becomes A into 0 plus B into minus 3.669. So I will get it to be minus 3.669 plus 8.888. That comes out to be 0.61926 into 5.219. That is equal to B into minus 3.669. So my B will be what? It comes out to be minus 0.88087. Okay, this is come wrong. 0.88087. Okay. So I found the value of A, I found the value of B. So I will substitute my I1 of S is equal to 1.5 divided by S plus B upon S plus 3.669. So that is minus 0.88087 upon S plus 3.669. So when I take the inverse Laplace transform, I get I1 of t is equal to 1.5 minus 0.88087 into e raised to minus 3.669 t into u of t. So we found out I1 of S.
Yes, sir.
How do we find out I2 of S now? Can anyone tell how will we find out I2 of S now?
Sir, given equation 1, by putting in equation 1.
Okay, okay. Okay, the links I will share. 1 minute. The link. You're able to see the link, right?
Okay, sir. Thank you, sir.
Yes, please 1 second.
Sorry?
Sir, please 1 second. Totally.
I couldn't hear what you're saying.
Sir, 1 second, please share the link.
Okay. It is here. Oh, once again. Okay.
Yes, sir. 1 second, please share the link.
Now I've shared it. Did you get? Are you able to see it?
Yes, sir. Yes, sir.
So you can subscribe to our YouTube channel and the drive link is there where I'll upload the notes. You can access the notes. Okay. Now I2 of S is equal to 1.2S, I1 of S upon 8 plus 0.9 S. You know what is I1 of S. I1 of S you found out to be like this. Okay, you substitute this in this equation and then you have to solve it. So it will become simpler. What will happen is certain factors will get cancelled. This factor will get cancelled and this S also will get cancelled. So it becomes a bit easier to solve for I2 of S. Okay, so I2 of S, I'll leave it for you guys. Okay. So I'll proceed to the next question. You're able to see this?
Yes, sir.
Yes, sir.
So how will you solve this? Or tell me what is given.
VC0 is given. Initial voltage of capacitor 10 volt.
Okay.
And initial current is 0 for inductor.
Why?
So initially the switch is off condition.
So,
There is no current in the inductor.
okay, sorry. Then what else is given? Can you tell what else is given? So I'll just come in 1 minute. Huh? Just hold on. Excuse me.
The class convert. Unit fault. The screen is paused.
Okay, sorry. You're able to see? I'm sorry.
Yes, sir. Yes, sir. Now,
So now this is our question.
Sir, can I solve this circuit code? Hello.
Can you solve this
Sir,
circuit?
using differential equation approach, second
Yes,
order
yes.
differential equation.
You can use second order differential equation approach as well. Both ways are you can use, but I actually prefer to use Laplace transform.
Okay.
Yeah. Because Laplace transform is easier according to me. But you can follow your approach. They have not told specifically you have to use Laplace transform alone. Okay.
Okay, sir.
Oh. Okay. Sorry. So now I will convert this. My VC of 0 minus it is given to be 10 volt. So I will convert this circuit. It will become to be 26 ohm. This will become 18 upon
18 by
S. This will become 2S. This will become 84 by S. And this will become plus minus 10 by S because of the initial voltage across the capacitor. And this is my I of S. Okay. So now, how will we solve? So we get I of S is equal to this voltage minus this voltage. That is 18 upon S minus 10 upon S divided by the total impedance. That is 26 is the resistance plus 2S plus 84 upon S. So I of S comes out to be 8 upon S divided by 26 plus 2S plus 84 by S. So my I of S comes out to be equal to 8. S goes in the denominator. It becomes 26S plus 2S square plus 84. I divide throughout by 2. It becomes 4 upon S square plus 13S plus 84 divided by 2 is 42. Okay. So we get what will be my I of S? Can you find out the factors?
Seven, 6.
Sorry?
S plus 7S
Uh,
plus 7S plus 6S plus 42. S common made S plus 7 plus 6 common made S plus 7. So 4 by S plus 7 whole into S plus 6.
correct. Okay. So this is 4 upon S plus 7 into S plus 6. So this I can write it to be of the form 1 upon S plus 6 minus 1 upon S plus 7. Okay, this is one shortcut I have. Yeah, I'll tell you how. So if I have 1 upon S plus A into 1 upon S plus B, it actually will be equal to 1 upon B minus A, whichever is bigger, into 1 upon, so suppose B is greater than A, B is greater than A. So it would be 1 upon B minus A into S plus A minus 1 upon S plus B. It will be of this form. So in our, this is one shortcut formula. Instead of going through the pain of doing partial fractions, I can use this formula. Okay, 1 upon S plus A into 1 upon S plus B, I can write it as 1 upon B minus A, where B is greater than A, into 1 upon S plus A minus 1 upon S plus B. So in my case, B is 7. In my case, B is equal to 7. Sorry. In our case, B is equal to 7 and A is equal to 6. Okay, that is why I have 7 minus 6 is 1. So it comes out to be 1. 4 divided by 1 into 1 upon S plus 6 minus 1 upon S plus 7. Okay. So now I will find the inverse Laplace transform of it. I will get I of S to be equal to I of t to be equal to 4 up into e raised to minus 60 minus 7 minus 4 into e raised to minus 70. Is this clear?
Yes, sir.
Okay. Now I need to find the voltage across the capacitor. So how will we find that? I have to find the voltage across the capacitor. That is this. This is the total is the voltage across the capacitor. And this is my current I of S. Okay, so my BC of S, how much? 84 by S. So sorry, my BC of S is equal to 10 by S plus 84 by S into I of S. So that is 10 by S plus 84 by S. What is I of S? My I of S is 4 upon S plus 7 into S plus 6. So that is equal to 4 upon S plus 7 into S plus 6. Okay. So I write it down further to be VC of S is equal to 10 into S plus 7 into S plus 6 plus 84 into 4 divided by S into S plus 7 into S plus 6. So that comes out to be VC of 10 into S square plus 13S plus 42 84 into 4 is how much? 336 divided by S upon S plus 6 into S plus 7. So this I write it down further to be VC of S is equal to 10S square plus 130S plus 420 plus 336 divided by S into S plus 6 into S plus 7. So I further write it down as VC of S is equal to 10S square plus 130S plus 420 plus 336. It becomes 6, 5, 756. So into S plus 6 into S plus 7. Is this clear? So now I have to find the partial fraction of this. So I will do partial fractions. I will get EC of S. And I can write it as A upon S plus B upon S plus 6 plus C upon S plus 7. So I write it down further as A into S plus 6 into S plus 7 plus B into S plus 7 plus C into S plus 6 divided by S into S plus 6 into S plus 7. So what I do, I compare this and this, and I will get 10S square plus 130S plus 756 is equal to A into S plus 6 into S plus 7 plus B into S plus 7 plus C into S plus 6. Is this part clear?
Yes, sir.
So what I will
Yes, sir.
I want to find A, B, and C. So first I will find A. If I want to find A, this should be there. All others should be eliminated. So if I put S equal to 0, if I put S equal to 0, this will go. B into 0 becomes 0. C into 0 will become 0. It will vanish. 10 into 0 square B is 0. So it will become 130 into 0 is 0. So this becomes 756 is equal to A into 6 into 7. Right? So it will give me my A is equal to 756 divided by 6 divided by 7. That comes out to be 18. It comes out to be 18. So simple. I want to find A, B, and C. So if I want to find A, I will try to eliminate B and C. So if I put S equal to 0, they will get eliminated. Now I want to find the value of B. So it has S plus 7. It does not have S plus 6. So what I will put, if I put S is equal to minus 6, what will happen? S plus 6 will become 0. That would mean S plus 6 equal to 0, it would imply. So this will become 0. This will also become 0. So I will get 10 into minus 6 square plus 130 into minus 6 plus 756 is equal to B into minus 6. Minus 6 plus 7 is 1, so it is 1. So what is 130? So what this will be? This will be 10 into 36. What is 130 into minus 6? So this becomes minus 70 plus 756 is equal to minus B6. So this becomes minus 70 plus 756 plus 360. That becomes equal to 336 is equal to minus 6B. Therefore, B is equal to minus 336 divided by 6. That comes out to be B is equal to minus 56. All right.
Yes, sir.
Now I want to find the value of C. So what I have to put? If I put
Minus 7.
equal to minus 7, that will imply S plus 7 is equal to 0. So A and B will go off. So it will become 10 into minus 7 square plus 130 into minus 7 plus 756 is equal to C into minus 7 into minus 7 plus 6. So that will turn out to be 490. What is 130 into minus 7?
910.
So that will become minus 910 plus 756 is equal to C into minus 7 into minus 1. So what is 490 minus 910 plus 756? That also comes out to be 336 is equal to C into 7. Okay, C into 7. Because minus and minus becomes plus. So my C will become equal to 336 divided by 7. That comes out to be C is equal to 48. All right. So now I will substitute that. I will get my VC of S is equal to A upon S plus B upon S plus 6 plus C upon S plus 7. So my VC of S, A is 18 upon S, B is minus 56. So sorry, it will be minus 56 divided by S plus 6. C is 48. So 48 divided by S plus 7. Now what will be its inverse Laplace transform? This will be 18 minus 56 e raised to minus 60 plus 48 into e raised to minus 70 into u of t. Okay. So any questions in this?
No, sir.
Oh, it was too fast, I feel like.
No, sir.
No hurry. Suresh Babu, any doubts?
No, sir.
Okay. So I will revise again what we did. Okay. First, I told why we go from Laplace transform to differential equations. All right. Why the boundary condition, initial condition, final condition, all that we have to consider. Then we finally get a solution. Instead, there's something known as Laplace transform, which makes it from a differential equation, it makes it into an algebraic equation.
Sir, please explain starting.
Huh?
Starting initial class.
So differential equations are very difficult to solve because there are many steps. So, and they have for the initial condition, final condition, all that we have to consider, and then we will get a solution. It is time consuming. Instead, there is Laplace transform, which converts the differential equations into form of algebraic expressions into like S plus A, S plus 2, S plus 5, S square plus 6S plus 9 into that form. So that's why we prefer Laplace transform. Okay. Then these are some of the very common Laplace transform formulas. Then, so these are well known. Then I told why we convert into partial fractions. How this is not easy to find a Laplace transform of this. There's no ready-made formula. And so we take its partial fractions and then we can find the inverse Laplace transform. Then I showed like for a resistor, it remains as a resistor. Inductors replaced by SL, capacitors replaced by 1 by SC as the impedance of that. Okay. Then we consider this sum where the capacitor had some initial voltage. So that we considered that, and then we found out the equation, we found out the impedance, we found out the current. I showed how to do division in case there are sort of fractional forms of division, how we must do. Then the current is there, we solved it, it takes some time. Then we found out it is of this form. Then we wanted to check if the roots are imaginary or not, if they are complex conjugates or not. So we found out that the roots are complex conjugates, and then we checked it satisfies this condition that B square is less than 4AC. So because they are complex conjugates, they have to be written in terms of some like this form, S square plus A square form. That is why I had to do this whole Tamash. In the 6S, I had to do 6 by 2 square. Then also, because I'm adding something, I have to subtract the same value. So I subtract the same value. Then I find it to be of the form S plus 3 the whole square plus 25. So 25 is 5 square. So this is a common thing which you guys would have learned in before your 10th, 12th sometime. This one, those time we didn't know what was the use, we just did. But like as we solve these equations, then you'll understand why those maths which you did in your 10th, 12th, they are important. Okay. Now we found I1 of S. We found its Laplace transform. This is the thing you must keep in mind. Then we I2 of S, we found it to be of this form. Okay, but this is S upon S plus C the whole square plus 5 square. It should be S plus 3. Okay, so what we did, we added plus 3 and minus 3. And then we got of this form. And then we found the inverse Laplace transform. We got it. This is the inverse Laplace transform. Then we have to convert in terms of sign. We use algebraic, we use trigonometric functions. The reasoning which we had with trigonometry we use to simplify it. And I've used generic A square and B square. And then we found it of this format. Then I have written what and all we did, like which and all formulas I've used. I have sort of explained it so that you can refer to it and you can do it. Okay. Then I found out this. Then I finally wrote my final expression. It will be of this format. Then my capacitor voltage is just a linear thing into I2 of S. So that also I wrote. So this is that sum. Question 2, it has mutual inductance is there. So because the mutual inductance is there, I first wrote the equation. I wrote the circuit in terms of the mutual inductance, the EMF due to the mutual inductance. Then what I did, I found out the Laplace transform of the equation. So 1.6 Henry becomes 1.6 S. 1.2 di2 by dt becomes 1.2 S into I2 of S. So I get two meshes are there. Then I apply KVL in the mesh 2. And I find I2 of S in terms of I1 of S. Then I apply KVL in mesh 1. Then I substitute I2 of S in this equation. And I get I1 of S to be of this form. Then I prefer this coefficient of S to be unity. So I take it out. Okay. And then I solve I1 of S. I solve it. After solving I1 of S, I get it of this form. I find the inverse Laplace transform. Similarly, you can do for I2 of S. Then in the last question, this is the RLC. Capacitor had some initial voltage, so that I had to consider over here. And then inductor 2H becomes 2S, capacitor 1 by 84 becomes 84 by S. Then I found out the current. In this case, if you see, over here also, this is a second order equation. But the roots of this are not complex conjugates. So we were easily able to find the inverse Laplace transform. We could do partial fractions of it. And we could get it of this format. And we found out the inverse Laplace transform of it. Okay, and similarly, we found the capacitor voltage. We wrote it down. It became very, very complex. Second order it became. We wrote like this. Then I told we can do the partial fractions. Okay. So we did the cross multiplied. We made the denominator common and then we equated the numerators. Then how to quickly find out the value of A, B, and C. If you want to find A, you want to eliminate B and C. So you put S equal to 0. They all get eliminated. If you want to find B, you put S equal to minus 6. So S plus 6 is equal to 0. That means this and this get eliminated. If you want to find C, you have to put S equal to minus 7. So then A and B part will get eliminated. Once you do that, you get the values of A, B, and C. And you substitute over here. And you find the inverse Laplace transform. Okay.